We have already talked about quadrilaterals and the slopes of the sides to compare them to classify the type of quadrilateral that it is. And now we're going to talk about how right triangles are formed inside some of our quadrilaterals. And we're going to use some of our right triangle properties and trig and special right triangles to find missing sides or angles. So first off, what special quadrilaterals have diagonals that are perpendicular? And those would be a rhombus. And if a rhombus has it, then so does a square. And then one more is also a kite, that they are all perpendicular in the middle. So that means where the diagonals meet each other in the middle, that they are 90 degrees. So what special quadrilaterals have right angles? And what I mean by that is on the edges of the corners are right angles. And that would be a rectangle and a square. And those are the only ones. So we need to remember that when we have a right triangle, we're going to be using Pythagorean theorem to find some of the missing sides if we're given two of them. Don't forget that your C value needs to be the hypotenuse of your right triangle. Don't forget also that in a right triangle, if we're given one angle and one side, we might need to use our trig or sine, cosine, tangent to find the other side or find one of the missing angles. Here are some of the pieces that we remember from sine, cosine, tangent, and we have our abbreviations right here to help us remember that it's opposite over hypotenuse, adjacent over hypotenuse, and then opposite over adjacent. And here are your trig ratios. Remember, a ratio is just a comparison of two sides, so we've got opposite over your hypotenuse. So if you need to, write those down in your notes so you can have those to refer back to on some of the questions we're going to do. In number 4, we have figure PQRS, so we know it's a rhombus, so we know that all four sides are going to be congruent to each other. We also know that the diagonals are bisecting each other, and we also know that the diagonals are perpendicular, so we have that they are bisected by having these pieces the same, and we know that the diagonals are perpendicular to each other, so it's 90 degrees in the center, and that's for all four of those triangles. So next, the diagonals are 8 and 16. Notice it does not tell us which one is 8 and which one is 16, so it's up to us to label it. Since the length of the diagonal is 8, that means that each of the pieces will be 4, so I'm going to make SE and EQ 4, and then the diagonals of the other one is 16, so that means that they are both going to be 8. So my PE and ER I'm going to make as 8. We need to find the perimeter in exact and rounded form to the nearest tenth. So we need to find out what the side length is. Now remember, we have right triangles. So if we have a right triangle right here, and I just redrew it so we can write some markings on there. If I'm going to label this as X, notice we can use Pythagorean theorem. So I can set up my 4 squared plus 8 squared equals my X squared. To simplify it then, we've got 16 plus 64, so that is 80 equals x squared. Now remember, we have to take the square root on both sides to undo that, and this is where you need to do your exact form, that we need to split the 8 into two different pairs, or 80, and if I choose a 5 and 16, then my 16 breaks down to 4 and 4, and there's a pair. Remember, the pair goes outside, the remaining number goes inside. So here's our exact form for just one of the sides. But we have 4 equal sides, so I need to multiply this by 4 sides. Now when I multiply it, remember we have to multiply just the outside numbers together and just the inside numbers together. So we get 16, and there is no other inside number, so that would be our perimeter. If we type this in the calculator to get the non-exact form, we get 35.777. And remember, we want to round to the nearest tenths place. We're stopping after the first 7. And because this next number is a 5 or above, we got to bump it up. So our non-exact answer would be 35.8. Now looking at to number 5, we know it is a rectangle. Now that I moved it so we can see everything, remember a rectangle that all 4 corners will be 90 degrees, and we will be using that to do a few things. Now if you notice, there are some right triangles created in here as well. It's not the triangles inside, it's not the 4 easiest ones to see. It's really, think of the diagonal is the hypotenuse. So there's 1, there's 2, and then it would go the other direction as well. There would be 4 of them overlapping. So when we label this, we know some things about rectangles. We know that the opposite sides will be congruent, so that's also 6. We also know that The diagonals are bisecting each other because it's a parallelogram. And because it is a rectangle, we know that the diagonals are congruent. So that means this whole length is congruent to this whole length. So if both of these are already 5, that means that the other two are also going to be 5. The last thing that we need to do is use this to find the perimeter. So we are missing the bottom side. So if you notice, we have one big triangle right here. This is the side that we want. The length of the whole diagonal is 10 because I'm putting the two pieces of 5 back together. And now I want you to set up what the x is going to be. I want you to set it up and solve for x. You should have gotten all of this. So we see that our c value is going to be the 10, and then the x and our 6 are going to be the a and the b. When we solve this for x, our missing side, we get that fg is 8. When we put that back in our picture, that gives us all 4 sides. So if we find our perimeter then, our perimeter, we would add up all 4 sides. So 8 plus 8 plus 6 plus 6. And we get 28 units. Now that you got that one, I'm going to go through this next one a little bit faster. This is a kite, so remember that we also have our diagonals are going to be perpendicular in the middle, so they intersect at 90 degrees. When we put all of our markings in our picture, we are trying to find what the length of BC is. But notice, this is one triangle right here, but the one big triangle is not a right triangle, so we can't really use that yet. But if we want to use this triangle, we're still missing this other piece. So we need to find BE first by using this other triangle. Then once we find the value of y, then we can plug it back into this bottom triangle and find what our final hypotenuse length is going to be. Now, if you notice, one of the things that we've been trying to do is giving you some Pythagorean triples. So with this Pythagorean theorem, if we set all this up as 4 squared plus y squared equals 5 squared, it is a Pythagorean triple by being 3, 4, 5. So already I know that the y value is going to be a 3. So now that I see that, I can use this bigger triangle to set up my last Pythagorean theorem to solve for the x. This is what I have so far. So we did our 3 squared plus 12 squared equals x squared. And then when we combine those together, we get 153 equals our y squared. And remember, we need to take the square root on both sides. So y, we need to take the square root of 153, but if you think about it, the only pairs that I came up with was 3 and 51, so there's no pairs. So also, we want to round to the nearest tenths place, so it makes it a little bit easier. That would give us 12.3693 as a couple of them, but tenths place stops after our 3 right here, so because this is a 6, we do need to bump it up. So that would be 12.4 for the length of BC. To start us out in number 7, go ahead and label the sides and just set up the places where we're going to put all 4 of our answers. We know that this is a rhombus, so again, we know all 4 sides are congruent, so that means we can carry this 25 over to all of the rest. We also know that they are 90 degrees in the center because the diagonals are perpendicular to each other, and that's already our first answer because the angle L to A to K, so the angle formed right here is 90 degrees, and that's from our diagonals being perpendicular to each other. With a rhombus, we know it is a parallelogram, and we know the opposite angles are congruent to each other. We also know that something special about a rhombus is that the diagonals bisect those angles. So that means that these two angles side by side will be congruent to each other. So this is also a 58. And because the angles are congruent, all 4 of these will be 58. Now, if you notice, we do have right triangles in here, and we have 2 of our angles out of the 3, so we could add the 2 together we have to subtract from 180 to figure out our missing angle. And I would like you now to go through and figure out what is that missing angle going to be. So when you add 90 and 58 together, that gives you 148. And that means that our missing angle is going to be 32 degrees when you subtract it. So this gives us 32 degrees. And for the same reason as our 58, these two angles are going to be congruent because the diagonal bisects that angle. And our opposite angles are congruent. So all 4 of those are going to be 32 degrees. So in our last answer over here, MKD is the angle created M to K to D, so that's this one right here, is 32 degrees. Now going on to finding the missing sides, we need to look at just one of the triangles. So I'm going to look at this one created right here. And we are not able to do Pythagorean theorem because we only have one of the sides. So this is where the trig can come in, where I'm going to base it off of my 32 degrees. So this is going to be my opposite, and then my 25 is my hypotenuse, and then this side would be adjacent. And I want to label them as my x and y, so I know what I'm finding. If I want to find what my x is, I'm going to have to use my hypotenuse. So adjacent and hypotenuse gives me cosine. Remember that cosine is, our angle is 32, and cosine is adjacent, so that would be x over hypotenuse of 25. Now don't forget, we have to cross multiply, so when we cross multiply, and don't forget it's in degrees in your mode in your calculator, when we do that, we get 21.2012, and that would be the length right here. So 21.2. That is what MA is asking for, so MA is 21.2. The next piece then that we are going to find is the y, so I need to do opposite and hypotenuse, so that would be sine. Now remember, sine of the angle is opposite over hypotenuse for our ratio, so the sine of the angle 32 degrees has the ratio of y over 25, and we're still going to cross multiply to solve for the y in that one. So when I do that, I get 13.24798, and now remember that's only this piece right here, and let's do 245 since I did not round that correctly. But for this last question for DL, I want the whole length, so I need to take that and I need to multiply by 2, so I will have 26.49596, so that's really going to be 26.5 for that diagonal. Same idea now with number 8 is put your 2 measurements in there with your picture and then set up where you can put all the 3 of your answers in the end. Then I take that back. There are 4 answers. I skipped one. So next we want to know that it is a rectangle. So we know the opposite sides are going to be congruent. So that's 12. We also know that there are 90 degrees in each of our 4 corners, which can then help us because if our angle given to us is at 30, the remainder is 60. We also know from previously on a previous question that for the rectangle, our diagonals are congruent, and we have the diagonals are bisected, which means all 4 are the same. Now remember, we know that we have an isosceles triangle here, so our opposite angles are going to be congruent. So this angle is 30, that means that this other angle is also 30 degrees. So it'll tell us the other piece is 60. We can treat that then the same way with this other triangle here on the right-hand side. Our isosceles triangle will give us those base angles being congruent, so this is also 60 degrees. And we're going to carry that around to the whole entire rectangle. We also know that we have triangles now created, so 30, 30, and our missing angle will need to add up to equal 180 degrees. 30 and 30 together gives us 60. That means the remaining angle is 180 minus 60 degrees, that'd be 120 degrees. So this is 120. The one right above it is a vertical angle, so it's also congruent. And then side by side is a linear pair. So these 2 angles side by side are linear pairs. They also are going to be supplementary. So we can subtract from 180, and that's how I got the 60. So notice all angles are now found, so we should be able to answer these 2 questions over here. So JFE. Let's see, J is right here, F and E, so that's this angle created right there is 60 degrees is the first answer. The next one then is G to J to H. So it's this inside angle right there is also 60 degrees. So now on for the side lengths, this is where the 12 is going to come in as well as our right triangle. So we need to find EG, that's the diagonal down here. So if we want to use the 12 we are given, we have one huge triangle we can look at. Now granted, you could use trig again, but I want to show you something else that you can do. Trig will only give you a non-exact answer for your answer. It will not give you an exact answer. So if you notice, this is a 30, 60, 90 triangle. And we had our ratio before that we had used. So when we have our x square root 3, and our 2x, remember our rule is that we need to set up the sides with those variables. So my smallest side is going to be this one. The next is x square root 3, and then my hypotenuse is my 2x. I need to label the sides with other variables just so I can find them. So I'm going to say this is z, and this hypotenuse is y. So remember, we start with the side with a number, and that's right here. So I need to set that equal to the ratio that is given. So x square root 3. I need to now solve for the square root of 3, or solve for the x, so I need to divide by the square root of 3 on both sides. And I get x equals, so my green x equals that 12 over the square root of 3. But remember, that's not simplified. We need to multiply by the square root of 3 on top and bottom to reduce it. Remember, this whole fraction really just equals a 1. So we get 12 square root 3. Remember, we cannot multiply those together. One's outside, one's inside. We get the square root of 9, but now that itself is just a plain 3, because the square root of 9 is 3. Then we can reduce the outsides. That gives us a 4 square root 3 is what my green x is going to equal. So if I take this, I want to put it back into the remaining two sides. This side would then be 4 square root 3. And this would be 2 times 4 square root 3, so that would be an 8 square root 3. So back in our picture, we know that this diagonal right here is going to be 8 square root 3, and then our side is 4 square root 3. So our other side will also be 4 square root 3. To fill that in with our answers then, our diagonal EG is 8 square root 3, and then JH, is this piece. So notice the diagonal is 8 square root 3, so I need to take the diagonal and divide that by 2, so we get back to our 4 square root 3 for just half of that diagonal.